Welcome to the channel. In today's video we're going to cover the repair of this Mitsubishi GTO 3000 GT climate control panel. As you can see, it's on the bench and we have the control computer from the car with a specially adapted cable form so that we can power up and test this unit. As you can see, it's powered up on the bench here, single 12-volt supply, and the unit isn't working, the display is off. You can see buttons work but no display, and this is pretty common on these units. So the first step is disassembly. So let's take a look at the common failure points on this unit. So if we zoom in here, the biggest cause of failure on these is leaking capacitors. So that's these guys here, and they leak electrolyte all over the board, and you can see this crusty black deposit here, which destroys the circuit in this area. These guys are non-functional when the circuit tracks underneath here get damaged. And we go over this way, you can see there's some secondary damage here where this resistor's drawn way too much current, burned the board. This is actually repairable, although there'll always be a mark on the board here, of course. This transistor usually survives, although sometimes this also fails. And all of this circuit here is basically a power supply for the display unit. So this power supply is now non-functional and results in black display, and sometimes you get red lines going across the display, which is the grid on the VFD display being supplied too much voltage. So the next stage is to clean and disassemble this board, and this requires, to do this properly, requires removal of the VFD display unit, which is on the other side here, and you can see there's a lot of pins here. And this has to be desoldered. So all of these pins here, these guys here, and on the other side behind this cable, all have to be removed. Okay, the next step is to clean the contamination off the board as much as possible to help desoldering. And we use something like this, which is a standard cleaning solvent designed for removing flux. We don't want to damage the board, so and this contamination around here on the board is usually quite tough, so you use something fairly benign like a toothpick. Soak it in the cleaner, agitate it with the brush to start with, and it'll start to break up the plaque that's stuck to the board. Very important stage this, because if you don't do this, you'll have real problems resoldering components and removing components from the board. Again, just give it agitation with the brush. Let the solvent do its work. Then we can come in with a toothpick, and we can apply quite a bit of pressure with the toothpick because it's pretty safe, and start to remove the plaque. We'll be doing more of this later as some of the components come off the board. This is a good starting point. Sometimes we'll need to apply something a bit harder to remove some of the plaque around the circuit pins. I use something like usually a pair of tweezers or a small screwdriver, but you have to be very careful, of course, when you do that, not to scratch the board and damage the tracks. Before we attempt to desolder the display, we need to make sure that all of the pins for the VFD display on the other side of the board are clean with fresh solder. This makes the life of the desoldering tool much easier. So I'm going with a regular soldering iron. I'm using a magnifier here to check the solder's flowing correctly. And we just go in with a regular iron, flow some soldering as if we were resoldering these pins. Now, sometimes this can be a bit difficult because the contamination of these pins is quite bad. It's quite hard to get the heat to flow into them. But again, this is a crucial step. If you don't do this, that's one done. There's no way you'll be able to desolder these pins. And the only way to do this repair properly is to remove this display, as you'll see a little later on in this video. So you can see these are quite hard to resolder. The desoldering tool we use is a professional pump driven desoldering tool. So a bit like this, and squeeze the trigger, creates a suction on the end and pulls the solder through the board. You can use the manual desoldering tools for this, the solder suckers, but in my experience it usually takes 2 soldering irons plus the desoldering tool to remove these. So yeah, this is a real labour saver and makes the job much more effective. So again, clean the tip, magnifying glass out the way, and then again apply some fresh solder at the point of heating. So gently work the pin, let the heat flow through the pad, and then take the sucker and just move gently around, and then we should find that that has really desoldered that pin. So if we have a look, there it is. Desoldered. So here are the pins desoldered. You'll see I use the soldering iron as well as the desoldering tool to get more heat into these pins, because these are the power supply pins. They tend to sink a lot more heat, which is why the manual desolder tools, solder suckers, don't work too well for this job. Now if we go in here with the tweezers, I can show you this. Where we go, yeah. And if I move these, you can see it's absolutely free and not in any way stuck, which means when we come to pull this guy out, you know, all these are going to come out without a problem because they're all loose. Usually if I rock the board, you can see them move a little bit like that. So now I've got to move along and do the others. And for most of these, we don't need the soldering iron and the desoldering tool. The desoldering tools usually have enough heat to remove these. Should now free our display. There we go. So display is free, and you can see this VFD looks like. The pins desoldered. You will straighten those obviously before we put it back in the board. That's the display off, and if we look at the pads on the board here, separate these two, so you can see that the pads are all perfect condition. Again, when this is all resoldered, it'll look brand new. Notice a couple of the heat marks here where the resistor has heated up the board from the other side. From here, again, not possible to remove those marks, but they do not affect the function of the board. So once we reassemble this with a new component in there, that will be fine. Just a point to note, sometimes these guys fall off. They just push in like that. So they do fall off, just put them to one side and you can just push them back in later. Okay, so the next step now is to start removing the old components from the board, and the components that need replacing vary depending on the failure of each particular unit. Somewhere between half a dozen and 10 components need to be replaced, and it's necessary to test the functionality and voltages at various points on the circuit to make sure that it's working correctly. Now we'll start removing. Some of these components have to be clipped, cut and then removed from underneath, and some of them can be just pulled out from the top. Again, techniques can vary. What works here for one person doesn't necessarily work for somebody else, so don't shoot me down for the technique I used to get these parts out. I've repaired about 30 of these units, and this technique works fine for me every time. So as before, I apply flux to the pins I'm going to desolder. Again, this just makes it easier to melt the solder and makes it easier to remove these parts. So a little bit of flux on here. Obviously, as an absolute minimum, these capacitors, in fact all capacitors on this board, need to be replaced because they're the cause of the problems. So you know, these two here in particular always leak. This one sometimes leaks over here, and occasionally these two, they're not so often, but we replace all of these even if they're not leaking. You can see here, actually, if you look here, you can see that the material from the leaking capacitors is spread all over here, and sometimes these components are salvageable and sometimes not. It just depends on how much damage this leaked electrolyte has done under these components here. So we'll start off by removing the offending capacitors, and all I did with this one is I tend to just put my finger under the back edge, heat the back pin until the solder melts, apply a little bit of pressure, and the capacitor will just come away on one side through the board like that, and then heat up the other one, and then do the same thing, bend the capacitor back the other way, and then wiggle it a little bit, and it will fall out the bottom of the board like so. So there it is, it's out. I don't know if you can see that. You can see the electrolyte, I think, on the bottom of there where it's kind of leaked. Yeah, that's the cause of the problem. You can see it's all bulged out too. This is dead. And if I bring up the circuit board here, you can see yeah, the electrolyte is underneath the capacitor there. You can see it, brown material stuck to the board, which is why we cleaned it once again when we've removed all of these components. You can see on here and the burn damage caused by that resistor burning. But we can clean that off, most of it at least. As I said earlier, the damage isn't fully repairable, but it won't affect the operation of the board afterwards. Okay, so we've removed all the components we're going to replace on the board, and now I'm going to give it another clean to get rid of the remaining plaque from the capacitors. Same process as before, we'll give it a wash with a solvent first and see what's remaining afterwards. You can see all of the black particles coming away from the board. See there how much is cleaned. Okay, so the next step is to begin inserting the new components. So now I'm going to clean out the via holes on the circuit board for all of these small components we've just removed, and again just use the desoldering tool for that purpose. So here are the components we're going to replace on this particular board, and as you can see, all of the components and we need to replace are removed, and the board's cleaned. And if we look at the other side, you can see that all of the holes are clean and ready to accept the components. Okay, that's all the components replaced. You'll notice that we've upgraded this regulator here to one that can carry higher current, mainly because the one that was in here is no longer available. Okay, now the next step is to go and repair the broken circuit board tracks that have been destroyed, by the leaking electrolyte. And again, the repairs vary from unit to unit. Sometimes it's one trace, sometimes none, sometimes 4 or 5. But you just have to go through and check them all with the meter. Okay, so I've gone through with the VFD display, straightened all the pins. So, they'll go straight back into the board. So next job, put that in the board. Okay, so I've refitted the VFD display in the board. At this point it's not soldered. I always run this test first to make sure that the unit's going to work. So I'm going to hold the display with my hand, just to press it in to get contact, and then power it up as a test. And there you go. You can see the display is now working. So now that's good. I know the rest of the circuit's working, and now I'll solder in the VFD back onto the main board. Okay, so let's solder the VFD in. I've turned the board upside down, and I'm just going to go through, do the corner pins first. I always apply a bit of pressure with my fingers, pushing down on here to make sure the pins are right in, and then just flow the first pin. Good soldering practice, just apply heat to the pad and the pin, apply solder. You can see those two are now soldered in. Let me carefully spin this around, turn that over that way, and then solder these pins, starting with the corner pins. That, and then this pin here. Okay, and then we can work our way all the way through here, soldering all these pins in place. Okay, so that's all the pins soldered back, and now we can retest. So turn the unit, go the right way, connect up power and signals into the back here. This, and then power on. There you go, all working. I've refitted all of the rubber switch caps around here, cleaned the flux off the solder pins, and I've replaced both of these bulbs. Now, if we switch it on, display comes back on, and around the back here I've connected up the dashboard illumination control wires. So if I touch this wire over here on the 12 volts, you'll see that the display dims and the illumination bulbs come on, which is the final test to make sure that the illumination works correctly. Now what we do is we simply cycle through these switches to make sure they all beep and work, so we can do temperature up. So, and we can then cycle through using the mode button, each of these, to make sure that all of these segments are illuminating correctly, like so. And then we can test the defrost and recirculate. So we go to fresh air here and recirculate here. The air comes up at the bottom, and then auto mode brings on the auto at the bottom. And then we can cycle through the AC. So just finishing cleaning the inside of the unit, just use this brush here to just remove the dust. So you have to be careful with these guys. They go into these switches in the back and they just fall out. They're not held in by anything. Just push those back into these holes here. Now we need to reassemble. So we start with the unit face down. Lift the two pieces, printed circuit board, hold it by the transformer there, and then slowly lower this piece on top of the switches. And then this piece here has two slots, one here, and these need to go over here. So just line those up like so, hold that vertical, and then just drop this down into place. It should sit flush at the ends here, which it does, and then we need to refit the screws. So we have longer screws that go into the 8 positions around the outside edge of the unit, so just put a couple of the corner ones in first to make sure the unit's not going to fall in half. Okay, so reassembled. Now we need to clean the outside of the case. Again, use this brush, and we can work around here and remove the dust from these little places here. Like that. Okay, now the best way to clean the rest of the case on the outside, I find, is to use a microfiber cloth with some hand sanitizer gel. This has got enough alcohol in it that it will clean the grease and dirt off the unit without damaging any of the fittings and finish. So start by wiping over the buttons here, and you can see the amount of dirt that comes off there. Wipe them over. There we go, and you can see on here there's a small amount of cosmetic damage on some of these buttons. Areas like this here, here and here, and small amounts here. And we can improve that to a certain degree with some black paint and the use of toothpick. It's just to very, very carefully drop a small amount of paint. That's the appropriate areas. So and I find that this ultra matte black is a pretty good match for most of these buttons, given the matte finish. I've just sprayed a small amount into the bottom of this plastic pot, and then I'll use the magnifier to do this, and then very carefully a small amount of paint on the toothpick, and then drop the paint directly onto the scratch. And just fill the scratch with the paint. Okay, and there we have it. Now, final test. We're going to reconnect the unit again, powering it back up from the back. Same connectors in the same place. So that one. Okay, so now we can check all the buttons work, and I'm actually going to do this with the lights off with the back illumination on. So I'm going to connect up the illumination and then power the unit on. We'll check it in the dark. Alright, so if we just turn this light off here, and we can power it up like this. Okay, and then if we turn off the main light, we'll be able to see the whole unit illuminated here. And all we do now at this point is just to go through the buttons to make sure they still work correctly. And you know, that one, and up and down, and the mode button, EC button, economy button, and then the off button. You can see these little fine lines on the grid on the camera, although in reality you can't see them by the naked eye. That's quite normal. There's a small amount of current going through the grids. Back on again, and of course you don't see them. The camera tends to overexpose, so it's a bit bright. And that's it. One complete unit, finished and tested. Back on again. There we go.